Yesterday, we talked about, like, if I give you key features of, like, a linear function or a nonlinear function or, like, a story problem like this, you can draw the graph. Today, I am going to give you a graph and a table. These are two different functions, and you're going to compare them. Okay, so let's note here. This function is your f of x, which it does say, and this function is your g of x. They're two different functions. Example 4 is comparing linear functions. So you're going to see why on your Go formative, it's like, I think it's 29 questions randomly. It's because it runs you through prompts, kind of like we're going to go through right here, where we're comparing x-intercepts, y-intercepts, slopes, and so on. It's really not that many problems, though. I just had to split it that way, so we didn't have a ton of partial points. So the first thing I want to compare, let's compare our x-intercepts. So remember when we talk about x-intercepts, the way x-intercepts are always written is that it's some x comma 0. So if you look at, let's start with f of x first. It's going to be a number comma 0. So what is my x-intercept for f of x? 3 comma 0. Now my picture is my g of x. From that picture, what is my x-intercept there? Negative 2, 0. It's this point right here, right? It's where it crosses the x-axis. So this would be like one question on your Go formative where there are two, fill in the blanks. But then the next question, which is like a separate question, is basically like which one's bigger or smaller. So in this case, we can say that f of x is greater than g of x. And in terms of like, and I'm talking about their x-intercepts, in terms of what that means that f of x is farther right. So with a linear function, we can compare their x-intercepts. There's a lot of writing in these notes too. Sorry. And we can compare then like kind of where they're at on the graph, because we don't actually have this graph, but we can still compare. So if we can compare x-intercepts, let's also compare y-intercepts. So this is the exact same functions. It's just we're like, first of all, it highlighted a different spot in the table. And then we're just going to write again, I guess. I don't know. I pulled this out of the book, and I thought this was 3 different examples for a while. And then I was like, wait, this is one example. So our y-intercepts here. And as a reminder, we should only have one x, one y for linear functions. And our y-intercept will be in the form 0, comma y. So from our table, what is my y-intercept for f of x? 0, negative 1. And then from my graph, what is my y-intercept for g of x? They kindly labeled it for us.
0,
yeah, 0, comma 4. So now when I compare which y-intercept is bigger, which is sort of a weird thing to like do, in this case, it would be that our y-intercept for f of x is less than the y-intercept for g of x. And in terms of like the actual graphs, what that means is that g of x is higher than f of x. So it ends up being higher up on the graph. Like g of x or f of x is going to intersect down here somewhere. All right, now the last thing to talk about and compare requires some review from Algebra 1 and geometry. Let's talk about slope. Does anyone remember the formula for slope? Okay, rise over run, so let's start with that. M equals rise over run. Or does anyone remember like the specific coordinate like formula for it? It's a fraction. What if I get you started? If I say y2, can you give me the rest of it?
Plus y1.
So close, not plus. Minus y1 over x2 minus x1. And we usually mix up if it's y or x on the bottom, but rise is your y. So that's why it's y on the top. So rise over run. The last way I want you to think of it is, and this is going to be funny notation, do like a triangle y over triangle x. What that triangle means is change in. And I like to write it that way because first of all, you might see that in one of your science classes. And second of all, it's kind of helpful for when you have a table finding the slope. I encourage students in Algebra 1 to use this formula because I think it's good practice, but we are in Algebra 2 now. So we're going to do this quickly from the table. So let's compare our slopes here. Our f of x slope. Remember, f of x is the table. If it helps, this f of x part is y. So if I want to look in the change in x and the change in y, basically, what would you have to do to go from -6 to -3? Add 3. So you can say that the change in x equals +3. How would you go from -3 to -2? Add 1. So the change in y is +1. So then if you kind of fill in this like formula, it would just be 1 over 3. Does that process make sense? It's going to be the quickest way to do it today. If you want to use this formula, go for it. You would just use -6 comma -3 as your x1, or y1, and then -3, -2 as your x2, y2, and then you can plug those in and you'd still get 1 over 3. Okay, so that's for finding slope from a table. From a graph, and I'll do this in pink just so. You're going to pick 2 points on the graph that actually like run into the grid. And you're going to count up how it changes on the x and how it changes on the y. So I said that backwards. How it changes on the y, how it changes on the x. So here we're going to go up 1, 2. That's my rise. And then to the left 1. Or to the right one, geez, I'm a mess. To the right one is also a +1. So our slope would be 2 over 1 or just 2. So these are both positive slopes. So what that means when I'm now comparing my slopes, we can say each function is increasing, right? If it's a positive slope, we know it's increasing. I don't know if you guys ever watched the Slope Man video. He's climbing up the mountain, Slope Man, yeah. But in terms of how they are increasing, g of x is steeper. We'll say, but g of x is steeper. Slope Man is getting more of a workout when he climbs up g of x. Does that whole process make sense? So on your Go formative, it really prompts you right through it, so you just kind of have to think about it as you're answering those. But that's for your linear functions. Here's the point where Mrs. Hopkins got frustrated of copying out of the book, and I just grabbed this whole screenshot of the page. So this is our comparison of nonlinear functions. So we're going to examine the categories to see how to use the description and the graph to identify key features of each function. Then we're going to complete the statements to compare the 2 functions. So there's a lot going on this page. Let's just break it down. We're going to compare x-intercepts. And this time we might have more than one x-intercept. We'll list them. We will only have one y-intercept. We may talk about extrema. So those are your maximums, your minimums, your relative maxes, relative mins. And then we will compare end behavior. Okay, so you're either going to see, and I honestly can't remember how I did it in the homework, you'll see just the one function listed out like this. So this is our f of x. This is our g of x. You'll definitely see one graph, and then you'll either see like a list or you might see a table. I think you see a list because I have to like tell you your relative max and min. Actually, no, you do have one table because the end behavior is tricky. So let's compare here. The first bullet point, so if you kind of like go down here to the bottom, it says the x-intercept of f of x is blank any of the x-intercepts of g of x. So if you look at the x-intercepts of f of x, it's negative 3.4 comma 0. So first of all, there's less x-intercepts than g of x because g of x has 3 of them. And it's less than the intercepts of g of x. So we're going to go ahead and put this first blank is less than. I'm sorry, we're going to squeeze it in. I literally just grabbed a screenshot, so the book writes small. I kind of answered the next bullet. The graph of g of x intersects the axis more times than f of x, right? It has 3 intercepts, whereas f of x only has the 1 x-intercept. All right, our y-intercept. For f of x, it's 0, 1.5. For g of x, it would be, let's see, 1, 2, 3. It'd be about 4 or 0, 4. Which one is bigger? 0, 4. So is f of x is bigger or g of x? F of x is bigger? G of x, because it's 4 compared to 1.5. So we'll say the y-intercept of f of x is less than the y-intercept of g of x. So what that means, if the y-intercept of f of x is less than, it means that g of x intersects the y-axis at a higher point than f of x. Then the relative maxima of f of x is blank the relative maximum of g of x. So if you look at the relative maximum of g of x, it's like, I don't know, maybe negative 0.5 comma 4.1, we'll say. And the relative maxima of f of x is that one. So they're really pretty close in terms of the y. We're just looking at the y, 4.7 versus 4.1. But 4.7 is a little bigger, so we will say that the relative maxima of f of x is greater than. We're really going to squeeze it in there, sorry. Greater than the relative maxima of g of x. Then we'll compare the relative minimum. So the relative minimum of f of x is negative 0.4 and 1.1. This one is our relative minimum of g of x. This is at about, let's see, 1.5 comma, we'll say negative 1. So the relative minimum of f of x, again, looking at the y value of it, 1.1 is bigger than negative 1. So the relative minimum of f of x is greater than the relative minimum of g of x. Because again, we're comparing how high they are. That's why we're just looking at the y part. Now the end behavior, this is probably going to be the trickiest. And it's going to be the trickiest just because we want to look at, actually they give it to us, look at that. So if you look at the end behavior here, it says for f of x, which is here, it says as you look to the left, it's going to negative infinity. As you look to the right, it's going to positive infinity. So all you're comparing is that as you look to the left, it's the same or different. As you look to the right, it's the same or different. And in fact, this one, as you look to the left for g of x, it's the exact same. As you look to the right for g of x, it's also going up. So in this case, the two functions have the same end behavior. I'm pretty sure I have one homework question that one of the functions is a table. Just do a real quick sketch of points so that you can kind of predict that end behavior, and then you can figure it out from there. That's it for this section. So your quiz that's on Thursday will include some comparisons, but really it's we'll just give you the two tables and then you choose an option for which is true. It's nothing too crazy. Go to your homework real quick.